Okay, so this is the lab portion for 9-1, and this is the introduction to hypothesis testing. So I'm just going to share my screen. Right now, you should be on page, let's see, 85. Yep, and then I'm just going to turn off this video. All right, so you're on page 85 right here, and this is testing a hypothesis. So hopefully you've had a chance to read through this first page. And what we're going to be doing, just like with the confidence intervals, is we're going to be talking about population proportions and population means. Population proportions and population means. So we did it with confidence intervals. Now we're going to do it with hypothesis tests. So the very first thing we want to do is just talk about what is a hypothesis. How do we write it? And that's what this section's about. And so here we have a claim that graduating students at our college have a mean GPA that is higher than 2.5. And so first we want to identify the population. So we're talking about graduating students at our college. So the population is going to be all graduating students at our college. The word all in there makes it for the population. Okay, so what variable is being examined in this problem, and is it categorical or quantitative? So this is a review of some of the vocabulary from chapter 1 and 2. And so what we're looking at is what's changing between the students, and that would be their GPA. And since GPA is a number, it is quantitative. So just as a reminder, quantitative is a number, and categorical is categories or words. And so, yes, GPA is words, but it's words that describe a number. And here we have our number 2.5 that we're comparing it to. So we are now looking for our parameter. So our parameter is going to be one of these two things that I circled, either the proportion or the mean. And in this example, we're talking about the mean GPA. Remember, parameter is the number that describes the population. So the number describing the population is the mean GPA in this problem. And so now that we know that it's the mean GPA, then this is definitely a problem about population mean. It says mean, so it's about the mean. It is not about the proportion. All right, number 2. More than half of all students at our college plan to vote in 2012. Well, first of all, I guess this could be updated a little bit to maybe some more current times, but that aside, first we want to identify the population. And so even though it says more than half, okay, that has nothing to do with the population. The population is all, so all students at our college. Is the variable being examined in this problem? What are they asking? And so what they would ask each person is, do they plan to vote? So whether students plan to vote. Now, if someone asks you, do you plan to vote? Think about your answer. Is your answer a word or is your answer a number? The question is, do you plan to vote? You're either going to say yes or you're going to say no. So this example is categorical because your answer is a word. Put in parentheses yes or no. Those are words, so that would be categorical. So again, up here we said GPA, but if someone said, what is your GPA? You would not answer GPA. You would answer the number that is your GPA. So that is why that previous problem was quantitative, whereas this problem is categorical. All right, so now we want to identify the parameter. What number are we evaluating about the population? And the parameter for this problem is, well, let's just look at the last one. The last one was the mean. This problem, the parameter is going to be the proportion of students who plan to vote. So we are not averaging anything together. We're going to survey these people. We're going to ask them, are you planning to vote, yes or no? And our conclusion, that number we would get at the end, would be what percentage of students plan to vote, or what proportion of students plan to vote. So once we can identify that it is proportion, then D is now done. It is population proportion. All right, so what we're gonna do, just a second, I'm seeing there's a lot of words coming up. Okay, so what happened is my page numbers are kind of weird. All right, so this is what we're gonna do. We are going to pause. I made a new slide just to pause. We're gonna pause the video and give you a chance to read through the next pages, and we will pick back up on. We're gonna pick back up after you've had a chance to read. So we'll be at the section that says try these. And we're back from the pause. So you've had a chance to read through all of this. If you're ignoring me, pause it now and go back and read through all of this, because like I said before, I'm not going to read it to you because that would be boring, but you do need to know what's going on. All right, so just to kind of summarize what you just saw, we have this new notation. We're going to be talking about opposing hypotheses. And so we call these the null hypothesis, and the alternative hypothesis, and they have this new notation. Null is like nothing, so it's like a 0 right here, and then alternative has an A, so there's an A right there. And so what we're going to do is we're going to practice writing the null and alternative hypotheses. And so we have our first claim from our first question. And this is graduating students at our college have a mean GPA that is higher than 2.5. And so the null hypothesis is pretty much restating that claim. Maybe just rearrange the words a little bit. Our null hypothesis is that we're focusing on the word equal. Null is always going to have the equals in it. And then the alternative hypothesis is what we're testing. That's the claim that we're testing. And so that is going to be greater than. You want to take the claim, take the question that they give you, and you want to write it using the symbols for inequalities. And so here, if I was to rewrite this in symbols, this is why I want to use greater than instead of higher than. It's just a small technicality. But if I was to write this in symbols, which we'll do in the next video, I would say for the null hypothesis, the mean is equal to 2.5. And for the alternative hypothesis, the mu is greater than 2.5. And so by using that word, that phrase is greater than in the writing of it, it just makes it easier to translate into symbols. Okay, so going to our question about voting. More than half of all students plan to vote in the upcoming election, or 2012. And so what we need to do is rewrite this as an equation, or not an equation, using equal to. So here we have the proportion. We already discussed this is a proportion problem. The proportion of the students who plan to vote is equal to, and you can either use the word half or you can just write out. So I'm using that equal, like I talked about before, for the null hypothesis. The alternative hypothesis, I'm going to write the same thing, the proportion of students who plan to vote is, and then now, since the problem stated more than half, then when I write this, I'm going to say greater than. All right, so again, going back to symbolic notation, I could say that the null hypothesis is that the proportion is equal to a half, and the alternative is that the proportion is greater than a half. What we're really emphasizing here is that the null hypothesis is writing the claim with an equal sign, and the alternative hypothesis is writing the claim. So the claim was more than half. So my alternative was the same as the claim, and I put greater than a half. And for the null, I just rewrote that, but with an equal sign. All right, finally, number 6. It says, here is a claim from a different question. Americans who are overweight and physically active have a higher risk of a heart attack than those who are normal weight but inactive. So what we want to say is here's our inequality word, lower. So we want to say, but inactive. So this is going to just take a second to kind of write out, but we'll just abbreviate. So we're going to say the proportion of Americans who are overweight / active, I'm just trying to shorten it, is equal to, so I took the lower word and I just changed it to equal. Is equal to, I guess I forgot to mention the risk of the heart attack, but the proportion of Americans who are, this is hard to word because I'm used to doing this in symbol. The proportion of Americans who are overweight and physically active and have heart attacks is, so I'll just draw a heart. A broken heart because it's a heart attack. Oh, sorry, heart. Is equal to the proportion of Americans who are normal weight but inactive. Okay, so then the null, that's the null, the equal to part right here is what we're focusing on for the null. And then just in the interest of time, because it takes a long time for me to write this out, I'm just gonna write same as claim. Int greater, oh, sorry, lower. I don't really like question number 6. There's too many words. So we're just going to go on to the next part of this. And so what I want you to do is, my favorite new slide, pause the video, and we are going to pick back up on page 90 with question number 1. So what I want you to do now is read up through page 90 and then come back when you are done. All right, and we are back. So you read this part 2. Again, if you haven't read it, I'm watching. Pause the video, read this right here. And what we're going to do here is talk about the conclusions. Or we're just going to talk about some more null and alternatives. And I'm going to, okay. So here, consider the claim more than half of all students at our college plan to vote. Give the null and alternative. So we're going to do this kind of whole problem. We did, this is redundant, I guess. However, all we did before was just give the null and alternative, and now we're going to kind of work through this problem a little bit. Okay, so the null was that the proportion was equal to a half, and the alternative was that the proportion was greater than a half. Okay, so now suppose we randomly sampled 200 students and found that 110 plan to vote, so 55% plan to vote. Does this mean that more than half of all students plan to vote? And so this is kind of what we're looking at. This is kind of the point of hypothesis testing, is this question right here. So in order to determine the answer, we need to ask, how unlikely would it be for a random sample of 200 in which 55% or more plan to vote, assuming the true population is 50%. And so the answer to this question is going to be the p-value. So look at the last paragraph under assess the evidence for an example. So we're going to go back up the part that you just read. Here's assess the evidence. Okay. So in this case that they talked about, the p-value tells us the sample mean is very unusual in the case with the GPA, assuming null hypothesis is true. If the mean GPA for students graduating from our college is actually 2.5, the sample mean of 2.62 or higher would only occur 0.2% of the time. Okay, so going back, okay, so it turns out the p-value is 0.08. So what that's saying is, you know, using that sentence that we just talked about, we would expect to see a sample proportion, which the symbol is p hat, of 55% or higher about 8% of the time. Okay, well, how does that compare to our level of significance? So in this problem, we're using a level of significance alpha, which we'll get into a lot more when we get into the 9.4 section. Should we accept or reject the null hypothesis? All right, so the p-value is 0.08. The alpha is 0.05. And so the p-value is greater than alpha. So we're going to say we do not have enough evidence to reject the null. can conclude about this claim. So we do not have enough evidence to say that more than half plan to vote. So we're just going to say the claim here. We do not have enough evidence to say more than half of all students. I didn't have enough evidence to reject, so let me just put some notes here. Not enough evidence to reject. No, I don't have enough evidence to say that it's not equal, so I can't make the claim that it is greater than a half. I don't have enough evidence to convince anyone that it's not equal. All right, where do all these numbers come from? That's a 9-4 question. Right now we're just practicing kind of how to put it all together, and we will actually be coming up with the p-values. We'll come up with a rule for when to accept or reject the null, or fail to reject the null, and we'll have pictures and all that fun stuff in chapter 9-4. So right now we're just kind of putting some pieces together, kind of a little uncomfortable, but just getting the feel of these problems. Okay, so the next section is on errors, which I am skipping, but what I want you to do now is pause the video, go ahead and work on page 93, numbers 1 through 3, and then when you're done, come back and check your answers. So number 93, problems 1, 2, and 3. And we're back. So here we have, let me get to my page 93. Here's some more practice. So we're just practicing. Oh, where are they? Let's do more. So there. Okay, so number 1, a drug company claims that an allergy medicine causes headaches in 5% of those who take it. A medical researcher believes that more than 5% get headaches. So the population will be all people who take this medication. Everyone that takes the allergy medication is the population. I don't want the whole world, because people who don't take this medication aren't being affected by the results. So I only want the people who are taking the medication, but I want all the people taking the medication. All right, so what variable is being examined? What question are they asking? What they want to know is whether or not a person gets a headache. The person who's taking this med. So that would be a yes or no question, which means categorical. It is a word, it is not a number, so it's categorical. Identify the parameters. So the parameter, we're just doing one parameter. Identify the parameter. So this is going to be the proportion of people who get a headache. Because that's what we are looking at. We are looking if this causes headaches. So I'm looking at the people who get a headache. And so since it's a proportion of people who get a headache, then this would be about a proportion. So going to the null and alternative hypothesis, the main problem, or not problem, the main number in this problem is the half. The claim is more than, not the half, that's not 50, that's 5. The claim is that more than 5% get the headaches. So that will be my alternative. The claim is the alternative. So my claim is that it is more than 0.5, which makes my null is going to be just like that claim, with the exception of the symbol. So the null is always an equal sign. All right, let's look at number 2. Nope, we are actually skipping number 2. I'll tell you this when I write it out. I know I said to do 1, 2, and 3, but this one has 2 populations, and we don't want to be comparing things with 2 populations. So skip, I will write that on Canvas so you don't remember to when you pause the video. All right, number 3. A student, so it starts. So this is number 3. A student claims that the quarter is not a fair coin. A fair coin is one where getting heads and tails is exactly 50, but unfair coin is where it's different from 50. Now it does not say greater than or less than, it just says different. Different means not equal. It could be greater than, it could be less than, it's just not the same. And so we're talking about a proportion here, and our null, no, I like to start with the claim. Our claim is that it is different from 50%. So our null is going to be that same setup, but with the equal to. All right, so now that you have seen this video, I want you to look at the 9-1 lecture, and what we're going to be focusing on is the null and the alternative hypothesis. And so I know it got a little different back in that last example we did. Okay, so this one was just kind of an introduction to what we're going to be seeing in 9-4, but we will be practicing this part, the 2, 3, and 4. We will be practicing this part of the hypothesis testing in a lot more detail. So what I want you to focus on now in section 9-1 is this part. So this is 9-1, and this will be discussed a lot more in 9. All right, thank you very much, and I will see you in the next section.